Welcome to Carlton's Math Corner. Today we're going to be talking about dividing fractions and mixed numbers. At this time, please make sure that you have your math journal out as well as your vocabulary packet. Make sure that in your vocab packet you are recording any definitions that you learn as well as a sketch of that term. Let's kind of refresh our memory on how to change a mixed number to an improper fraction, because we will be using this knowledge to complete our target today. So how do I change 5 6/7 to an improper fraction? Now remember, the 5 stands for 5 wholes of something. 5 whole pizzas, 5 whole cookies, 5 whole, even just a rectangle. But it stands for 5 whole amounts. And then we have a fractional amount of 6/7. Now this seventh down here in the denominator's place is telling us that our whole, each one of these wholes is separated into 7 equal parts. So first of all, what I need to know is how many 7s do I have in 5 wholes? Exactly. If I take 5 times 7, I know that there are 35 wholes, or 35 sevenths within those 5 wholes. Now, I do have some additional sevenths though. I have 6 additional sevenths, and that is added to it. So I need to make sure that I'm adding that 6 on to my 35. So 35 plus 6 is, 41 sevenths, and that's how many sevenths I have. So the improper fraction, 41 sevenths, is equivalent to 5 6/7. How about 3 8/9? Yes. If I do 3 times 9 is 27, plus 8 is what? 35. Nice job. Okay, so we have 35. Oops. 35, and in this case we have ninths. That's what my whole amount is separated into, is 9 equal parts. And I can check this out. 9 goes into 35 3 times, and that would get me 27, and then there'd be 8 left over. 8 ninths would get us back to our mixed number. So 35 ninths is equivalent to 3 8/9. Let's take a look at this image. What do you notice? Well, first of all, what do you notice? And then what do you know about division? Excellent observations. If you look at this rectangle above, do you notice that it is separated into 3 equal rows? Okay, and out of those 3 equal rows, how many are shaded? Well, there's 2 full rows that are shaded out of 3. Excellent. Now, over here, if you look at this rectangle, notice that there is 1, 6. Notice there's 6 equal columns, and 1 6 is shaded. 1 column out of 6 columns are shaded. Now, what if I asked you, because remember, I asked, what do you know about division? And some things that you might have said or thought of is how many times does 1 6 go into 2/3? Or look at it as 1/3 is separated into 1 6 equal parts. And I know that sounds different because we're using fractions, But let's look at a visual. If this is 1/6 and this is 2/3 of this same rectangle, both of them are identical rectangles, and I ask you how many of these 1/6 would fit inside of the 2/3, what would you say? Okay, so let's check and see if your answer is correct. So notice 1/6 is how many rectangles? 1, 2, 3. So let's shade 1, 2, 3. And I know it didn't come out evenly, but oops. So if I have, let's try that again. If I have, so this is 1/6, there's 1, then here's another 1/6, there's 2, and here's another 1/6, 3, and lastly here's another 1/6, 4. So how many times did 1/6 go into 2/3? It went in there evenly 4 times. Now you're probably asking yourself, how would you get an answer of 4 looking at 2/3 divided by 1/6? Well, that's what we're going to learn today. And a lot of it has to do with what we learned about reciprocals and multiplicative inverses. And so remember in the last video we talked about multiplicative inverse as being a switch. Basically, the multiplicative inverse of 1/6 would be 6 firsts. And the reason why I know that is because if I multiply these two together, I would get 1 times 6 because they're both numerators, so I multiply them together. 1 times 6 is 6, and the 6 times 1 would be 6. So 6 over 6 is 1 whole. So I know that they are a multiplicative inverse. Well, we're going to be using that knowledge to solve a division problem without creating a visual. I just wanted you to see a visual so that you can at least see what we're doing. And so let's take a look at another problem. What if I asked you to find 3/4 divided by 1/2? And here's a visual. Okay, so here's a pie. There's 3/4 that's shaded. And I want to know how many halves would go into 3/4. Think about how big a half is. Well, how many fourths does it take to make a half? Well, it takes 1, right? 1, 2. 2/4 would make a half because that would be half of the pie, correct? So that means there's at least 1/2 that would go inside this 3/4, correct? Well, what about this last piece? How many halves is that last piece? Yeah, it's not even a full half, is it? It is half of a half, if that makes sense. So really, there's only 1/2 and a half. 1.5 halves that would go into 3/4. And let me show you in a more simplistic way. If I write out 3/4 divided by a half, and I follow the following steps. What I'm going to do is I'm going to write the reciprocal, meaning the multiplicative inverse of 1/2. What is that? What is the multiplicative inverse of 1/2? 2 over 1. And so what I'm going to do is I am going to keep this 3/4 as is, and then look at the second step. It says multiply the fractions. So I'm going to change to multiplication, and I'm going to switch to the multiplicative inverse. And so keep, change, switch. So this is what it looks like. If I do that, I take 3/4, I keep it the same, change to multiplication, and switch to 2/1, or 2/1. And now when I multiply this, if I can simplify first, or I can multiply straight across and then simplify later. And so 3 times 2 is 6, 4 times 1 is 4. 6/4 is an improper fraction. And I don't ever want to leave it like that, so I'm going to change it to a mixed number. How many times does 4 go into 6? It goes in there one time, and how many's left over? 2/4. Well, 2/4 is the same as 1/2. Yeah, because we can divide the 2 and the 4 by a 2. And so I can get 1/2. So 1.5 would be my answer. And so let's try a few other problems. So we're going to keep, change, switch. Remember our little switch for reciprocal or multiplicative inverse? So this is what we did. We kept the 3/4, we changed to multiplication, and then we flipped or switched. And so we set up the problem, and then now it's just a multiplication problem. And we have learned how to multiply fractions already. And so we're using that knowledge now with division. And the reason why we're switching it to multiplication is because it is much easier to just multiply two fractions and multiply the numerators and multiply the denominators than trying to figure out how many fractional pieces will go into another fraction. That is very difficult to figure out. And so that's why we're doing these 3 steps: keep, change, switch. Okay? And so let's do a few problems. If I have 2/3 divided by 1/3, so the first thing I'm going to do is keep, change, switch, KCS. So we're going to keep the 2/3 as is. And what happens to the division sign? Division sign goes to multiplication, yep. And then what happens to the 1/3? The 1/3 changes, it switches. And so the multiplicative inverse for that is 3/1. And so now we have a multiplication problem. Is there anything to simplify? Like if I look at the numerators, is there something in the numerators that can be paired up with the denominators? Well, the 3 and the 3 can be paired up. 3/3 can be simplified to 1/1. I mean, it simplifies to 1. And so now I can multiply. What's 2 times 1 is 2. And 1 times 1 is 1. And I don't need the 1. I can keep it. It will never be marked wrong. But 2/1 is the same as 2. Okay, so let's try one more before I give you your ticket problems. Find 5/3 divided by 1/6. Okay, so think about it. Remember, keep, change, switch. And what would it look like? And how would you find that answer? Okay, so let's find the quotient. And so 5/3 would remain the same. Times, so keep, change to multiplication, and switch, 6/1. And notice 6/3 can be simplified to 2/1. So now we have 5 times 2 is 10, and 1 times 1 is 1. So it'd be 10/1, or the equivalent is just 10. So for tonight, what I would like for you to do is to try these 4 problems. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.